What astronomers had concluded to be a black hole a mere 1,120 light-years from Earth instead appears to be something quite different, a two-star system where one of the stars is sucking the life out of the other. Far from disappointing, though, the conclusion gives astronomers an exciting opportunity to explore how these vampiric stars evolve. To backtrack, the suggestion that the star system may have harbored a black hole was speculative to begin with, relying on a couple of unchecked assumptions. When first identified in the 1980s, the cosmic object known as HR 6819 was presumed to be a single, rapidly spinning object called a B-star. A closer look at its light decades later revealed it had a partner snuggled up relatively close, orbiting once every 40 days. 2 years ago, researchers from the European Southern Observatory argued the B-star should be wobbling more than it was, hinting at an additional unseen mass throwing its weight into the mix. Studies have since cast doubt on the black hole hypothesis, however, suggesting the partner could have far less mass than that used in their calculations. A stripped-down, more lightweight companion wouldn't have the grunt to pull the B-star out of line, making any notion of a third object redundant. Still, the idea of having a black hole so incredibly close to us was worth exploring, at least until it could be ruled out completely. So 2 teams of researchers, including scientists from the original ESO team, joined forces to collect the necessary data for tipping the balance in favor of one hypothesis over the other. The key difference between the 2 scenarios was a matter of space. If there were 3 objects, an invisible black hole, a bright main sequence star, and a radiant B-star, the distance separating the 2 glowing objects would be a respectable gap. If there's just the 2 objects, they'd only need to be separated by a tiny fraction of that distance. We had reached the limit of the existing data, so we had to turn to a different observational strategy to decide between the 2 scenarios proposed by the 2 teams, says lead researcher Abigail Frost, an astrophysicist from Katholieke Universiteit Leuven in Belgium. That strategy involved using the ESO's Very Large Telescope, VLT, and a light comparison tool on the Very Large Telescope Interferometer, VLTI. Sure enough, the instruments on the VLT found there was nothing glowing brightly at the wider distance of around 100 milliarseconds. The VLTI confirmed instead that the stars sit right up close to one another, at just 1 milliarsecond. In other words, this means no black hole is required. They're just 2 ordinary stars in a garden variety binary relationship. Note that ordinary here doesn't imply boring. We're seeing the pair at a very specific stage close to stellar retirement, a moment where one partner has recently drained its partner of its atmosphere, like some kind of cosmic vampire. Catching such a post-interaction phase is extremely difficult as it is so short, says Frost. This makes our findings for HR 6819 very exciting, as it presents a perfect candidate to study how this vampirism affects the evolution of massive stars, and in turn the formation of their associated phenomena including gravitational waves and violent supernova explosions. Sure, having a stellar-sized black hole just down the street would have been a boon for astronomy. But a satisfied vampire and its victim on our doorstep is still a discovery that will tell us a lot about the weird ways our universe works.